Hello everyone, this is Team 34 presenting their Operating Systems Lab project. Our topic is Implementations of Page Replacement Algorithm with Pleiades Anomaly in GUI. Our team consists of Ronak Makwana, Prachi Doshi, Prathvesh Shah and Parv Chauhan. To implement this GUI, we have used Java programming language and Eclipse IDE version 4.13 and above. In the Java framework, we have used concepts of Swing, AWT Designer, Threads, Exception Handling and have also used external libraries such as JFreeChart for graph visualization and VLCJ to embed a video into it. So, let's check out our desktop application. So, as you can see right in front of you, this is our Eclipse screen, and as you can see we have already written all the codes in this operating system project. Our first page of the project is our home page. So let me show you after running it. The screen that you see is the first home page screen. The home page screen is divided into two panels, the side panel and the main panel. The side panel consists of three navigation buttons, that is first the home button, second the algorithms button and third the simulation button. The algorithm buttons takes you to the algorithm implementations page and the simulation button takes you to the simulation implementation page. The another panel, that is the second main panel, is divided into three parts with what, why and where buttons. The what button represents that what is page replacement algorithm, the why button represents why do we need page replacement algorithm, and the where button represents that where else can we use the page replacement algorithm. So let's check out all the three buttons. For the first, let's check out the what button. When you click on what button, a new frame opens up telling you a text area with what is page replacement algorithm all about. It's a brief description of what the page replacement algorithm is all about. In case if your home page closes off when you open this what button, we have already given the navigation button and all the three of buttons are working. So you can transit from here to there in the whole JFrame, in the whole application. The second button is why. So as you can see, we have already implemented our why do we need page replacement algorithm. So as you can see, we have briefly described why do we need page replacement algorithm in case of operating systems. And the third part is where. So where else can we use the page replacement algorithm has also been mentioned in this whole brief description. And this examples is application apart from operating systems. Now let me take you to the part 2 of our video, and that is the algorithms tab. Now when I clicked this icon, it took me to the algorithms tab. Now we have implemented three algorithms, that is FIFO, least recently used and optimal page replacement. All the three algorithms contains the table as well as the hit ratio as well as the number of fault pages and a graph embedded within it. So let's first check out FIFO. Okay, so let me enter the number of frames. Okay, so as you can see, we can input as many number of frames that we want. As of now, I've used number 3, and in the input page number, you can see it is dynamic, and hence you can input as many page numbers as you want. When I will be clicking on the implement button, it will run the program in the backend and will give you an output in the table format that where the page fault occurred and where the page hit occurred. The total page fault will depict that how many page faults occur in the algorithm, and the hit rate will occur that what is the hit ratio of this algorithm for this particular example. So as you can see, there are 9 page faults and only 1 hit, and that is why the hit ratio was 10% only. Now when you click on the reset graph, everything is reset to 0 and you can implement for the next algorithm. And it can be implemented infinite number of times. Now when I click on graph, the graph is produced for the example that we have inputted in the back. So you get a comparison graph between optimal, LRU and FIFO. As of now, we implemented FIFO, so you get a comparison graph for the very same example that we implemented just now in the graph format. Now let's check out the second part, and that is least recently used. I'll be inputting the page frame 4 over here to show you that you can input as many page frames that you want. Once I click on implement, you can see that only the last row, every time only the last row will be showing that where was page fault and where was page hit. In this case, all of them are page fault, and it is sad to see. This reset button works similar to that worked in FIFO. And now I'll show you the graph button. So as you can see, the graph is also dynamic. It keeps changing with the example that you have implemented over here. The blue color is for FIFO, the red color is for LRU, and the green color is for OPR. As of now, if you implement FIFO or if you implement LRU, it is same, and hence the graph is overlapping in the case of FIFO as well as LRU. Okay, so let's check out. I'm so sorry, I mistakenly closed the application. Yeah. Yeah. So we'll go for optimal page replacement algorithm. Yeah. Now I'm implementing for 5 frames. Make sure in all the cases your input page numbers are separated by spaces. So as you can see, we have implemented it for the 5 page frames, and you can see the table output right in front of you. And when you click on graph, yeah, it will showcase the comparison graph. Now let's check out a simulation tab. Okay, so simulator tab consists also the implementations of 3 algorithms, and all the 3 as is a video animation of all the 3 algorithms, and hence once I click on that particular button, there will be a voice over working behind, and that is why I'll keep myself mute so that you can hear out the voiceover. Today, let's study FIFO page replacement algorithm. Pertaining to its name, FIFO follows the structure similar to GUI, which follows the method first in, first out, which means that the first page to occur inside the frame in the GUI will be removed when the time comes. FIFO majorly suffers from Blade's anomaly. Let's check an example on it. The input page numbers are 7201208 and the frame size is 3. Now when 7 appears for the memory allocations, since the frame is empty, first place will be allocated to 7 and a page fault will occur. Similarly, when 2 appears for memory allocation, since the frame size is still left, second place will be allocated to 2. Now when 0 appears for memory allocation, the third. Today, let's study LRU page replacement algorithm. LRU stands for least recently used, which means that it replaces the page that hasn't been referenced for the longest time in the gone string. To learn more about it, let's check out an example. The input page number consists of 7201208 and the frame size is 3. Now when 7 approaches for memory allocation, we see that the frame is empty and hence the first place will be allocated to 7 and the page fault will occur. When today, Let's study OPR page replacement algorithm. OPR stands for optimal page replacement. OPR is considered to be the most efficient page replacement algorithm. The working of the OPR says that it replaces the page which is not going to be referenced in the near future, and hence it keeps the memory for which pages are going to be visited in future, and by keeping such track it makes sure that the most frequently needed pages are not replaced. To have more insight about it, let's check out an example. For the example, we have input page numbers as 720122087 and the frame size is 3. When 7 approaches for the memory allocation, we see that the frame is empty and hence the first place is allocated to 7 and the first page fault occurs. Now, when 2 approaches for memory allocation, we see that we still have space into the frame and hence the second place is allocated to 2 and the second page fault occurs. As you saw, there were 3 videos that we played. I did not play it like whole video because they are like a little bit of lengthy videos, but I showed you a little bit of glimpse of how all the 3 videos are going to work with a voice over, and yes, that it is. Thus we conclude our presentation. This is our whole project and we have tried our best to explain the page replacement algorithms with Blady's anomaly, and we hope that you like our project, and thank you so much for supporting us and giving us the chance to create a GUI and learn something good.